57 reads, which of the following is a graph in the standard x, y coordinate plane of y equals x squared plus 3x, everything divided by x? So to figure this problem out, there's a couple of things that we need to review. First of all, the equation y equals x squared plus 3x, everything divided by x, seems to be a second degree quadratic function. It's actually, because you have a variable on the denominator, it's a rational function because you have a ratio or a division. And so you have to be very careful with this one. There's two things we can do. You can either plug this into your TI, which is a really simple thing to do. If you plug this equation, the exact equation on the TI, if you know what you're, how to key it in correctly, you'll be able to see which graph this corresponds to. There's another way of doing this. You can actually factor out an x from the numerator, like this. Oops, sorry. What I did was, the two terms on the denominator both contain x. The first one contains two of them, multiplying. That's what x squared stands for. The second one contains a single x, 3 times x. So if we take out an x from each of those terms, we are left with x times x plus 3 as a factored form of the numerator. Now, at this stage, notice how you have a continuous multiplication link on the numerator as far as the parentheses here is concerned, because you would just do this continuous multiplication link. It doesn't matter if inside the parentheses you have things adding. From the point of view of the numerator, y view, if you will, you have an x times a parentheses, and so it is a continuous multiplication link. On the denominator, you have a single x. That means that this x right here can cancel with this x right here. X divided by x is 1. Just be careful. One of the values that you would never be able to plug into this equation is x being equal to 0, because then you would have an expression of something divided by 0, which can never happen. It's undefined. So we need to just remember when we do things like this that x can never be 0. So in the next step, we would simply write y is equal to x plus 3. Now, this is, for all practical purposes, what you can use to graph. The only issue is that x cannot be 0, so there would have to be an open circle there wherever the graph lies, so that you know that that value would never be allowed to be plugged in. Okay, so if we look at these graphs, which one is a match for y equals x plus 3? Well, this is just a linear equation. The slope is 1. That, remember, is rise over run. And then this right here is a y-intercept point. So we plug that into the x comma y format coordinate point. X is 0, so y is this value right here, 0, 3. So look for a graph that has a line, this is the equation of a straight line, a line passing through 0, 3. And the only one that has that is choice D, right here. Now, strictly speaking, the graph for this would need to look like as follows. There would need to be a hole at 0, 3, because you can never plug in 0 for x. Again, if you plug in 0 for x, you're going to end up with something divided by 0, and you can't have that. Never. It's undefined. So there would be a hole there. And then the slope is 1, which means that if you go up 1 and then forward 1, you find the next point on the graph, etc. So with that, you can just connect. And this is the graph of y equals x squared plus 3x, everything divided by x. So choice D is correct. Problem 57, you can use the graphing functionality again of the TI. You go to y equals, clear any equations that you may have there with the clear key once you're on that line. So now that I've cleared both y1 and y2, the first and second equations, I'm just going to use that first equation there, that first line. And because the formula says x squared plus 3x, everything divided by x, I open a parentheses. X, remember, is this key, squared, and then plus 3x, so plus 3 and then the x. Then I need to close the parentheses. And I'm going to be dividing by the x. If there were more things on the denominator, then remember, you would want to open a parenthesis, say it was x minus 1 or whatever, then you would do something like this. Please be careful with that, assuming everything was in the denominator. In this case, just the x was in the denominator, so there's no need to do that. So I'm just going to delete all of this, and again, just divide it by and the single x. No need for the parentheses because I only have one element on the denominator. Now if I go to graph, now notice that it crosses at -1, -2, -3, comma 0. And then notice that it crosses at 1, 2, 3, so 0, comma 3. The only one that has that characteristic is choice D. D is correct. 58 reads, a triangle ABD, is reflected across the y-axis to have the image triangle A prime, B prime, D prime in the standard xy coordinate plane. Thus, A reflects to A prime. The coordinates of point A are m, n. What are the coordinates of point A prime? So it always helps in problems like these if you just do a very, very quick sketch. So this is the xy coordinate plane. It says that we have a triangle ABD, and it's going to be reflected into A prime, B prime, D prime. A reflects to A prime. And then it says that the coordinates of point A are m, n. And notice that they're both positives. So what we can imagine is just a triangle where point A of that triangle is located somewhere on the first quadrant. And we would call this M, and we would call this N. Now, it doesn't matter where we put the other 2 points. They're not telling us how B and D are, if they're positive, negative, anything, but it really won't affect the outcome. So what I'll do is I'll just imagine that this is point B, and that, say, this is point D. It doesn't matter where you draw them. Again, they're not saying anything about B and D, so it could be on the second quadrant, third quadrant, but we'll keep it simple. So we'll just draw this triangle right here. And it'll be valid because we're just focusing on the A and on its signs. Point A right here, as according to the problem, has a positive m and a positive n value. Now, if it's reflected across the y-axis, well, this is the y-axis. So reflected across the y-axis means this way. And so it says, thus A reflects into A prime. The coordinates of point A are m, n. So what are the points of A prime? Well, if you reflect something across the y-axis, like the prompt is asking us to do, what you're doing essentially is you're taking this distance and then applying it, but towards the left. And so if point A is here, its reflection is going to be here. We would call that A prime. So for B, this distance right here, same distance, but towards the left. So it would be somewhere here. That would be B prime. And then the same thing for D. So that's going to be more or less about there. I'm just eyeballing it. There's no need to be more precise than that. And this would be D prime. So this is the outcome. You're simply reflecting the triangle across the y-axis in this way. Now, what they want us to say, what are the coordinates of point A prime? Well, it's going to have the same n value, the y value, the height, because look, you're just reflecting it across the y-axis, so you're just shifting it from here to here across this, across the x-axis. So you're not really affecting the height of the point. Therefore, A prime is going to have, comma, n, the same n value. Now, with the same positive sign. So that right away tells us that, F seems to be right because G is negative n, H is negative n, J is reversing the values, makes no sense in this prompt, and K cannot be determined, that's false. What about the M value? Well, say M was positive 3. Well, its reflection would be -1, -2, -3. It would be found on -3. So essentially it becomes negative m. Think about it. So the coordinate was, for A prime is going to be negative m, comma, n, which is again choice. 59 reads, if x equals 3r minus 4 and y equals 3r plus 2, which of the following expresses y in terms of x? So we have on one hand, x is equal to 3r minus 4. And then on the other, we have y is equal to 3 times r and then plus 2. But they want us to come up with something that expresses y equals in terms of, and then whatever, but where x is going to be found. Currently, if we look at the y equals statement, we have it in terms of r. And so we need to change that. We need to have x instead of r. That doesn't mean you simply change the r for an x. That, of course, makes no sense. So we need to know what r is equal to in terms of x, so that we can then replace r in terms of x with that statement or that expression into this, into the second one. So look at the first expression they give us. X equals 3r minus 4. We want to solve for r. Why do we want to solve for r? Because that way we'll be able to plug in to the second one, replace this r with whatever we find on once we solve for r. It'll be in terms of x, and then we'll be able to answer this question correctly. So how do we solve x equals 3r minus 4 for r? Very simple. So one of the things I always advise students is don't worry if your variable, the one you're solving for, is on the right side. It can stay there. That's not a problem. I always say that, you know, if x equals 2, you can just as easily say that 2 is equal to x. I mean, it's the exact same thing. So don't worry about having to put things on the other side, those elements that you're solving for are variables. In this case, what I want to do is just take this subtracting 4 and send it to the other side. I achieve that by adding 4 to both sides. Remember, the equations are like scale balances. So it's like this type of scale balances. I don't know if you've seen this, where you put a weight on one side, and if the weight on the other side is exactly the same, then this will be perfectly balanced. That's what equations should be treated. So whatever you do to one side of the equation, you better be doing the exact same thing to the entire other side. Otherwise, it'll become unbalanced, and then you'll lose the equality relationship. Okay, so adding 4 to both sides will give us x plus 4 on the left side equals, and then we have a 3r minus 4 plus 4. Well, minus 4 plus 4 becomes minus 0 or plus 0, so essentially 3r. Now we're solving for r, so we just need to get rid of this multiplying 3 times r. So the opposite of multiplication is division, so if we divide the entire both sides by 3, be careful here, look what I did to the entire left side, we'll be able to continuous multiplication link here, yes, cancel these 3, so you're left with the r, what we were solving for, and now we know what r is equal to in terms of x. Take a look. If you're bothered by the fact that the variable we solve for is on the right side, then switch it. R is equal to x plus 4, everything divided by 3. Okay, but there was no need to do that. But just, you know, if you're uncomfortable, switch it, not a problem. Okay, so now that we know what r is equal to in terms of x, we can go back to equation 2 and say, okay, y equals 3 times, now I'm going to open a parenthesis here and plug in the r value we found, x plus 4 divided by 3, or this one, it's the same one. So x plus 4 divided by 3, close the big parentheses, and then a plus 2. Remember, you need to plug in with parentheses always. Otherwise, you're going to end up with making some serious mistakes. Now, let's analyze this for a sec. Yeah, sure, you can take this 3 that's multiplying a fraction, put it in fraction form, and then just multiply straight across, but you're not going to end up with a statement, an expression that will allow you to choose the correct answer. You need to be able to see something. You're multiplying 3 times something, okay? It's what's inside this parentheses. But that something is being divided by 3. Remember, 3 times and then dividing by 3, essentially, you're going to be able to cancel those 3's. Another way of seeing that is to, say, express it as 3 divided by 1 times, let's put the x plus 4 in the numerator in parentheses, and then divide it by 3. Well, I can just, never mind the plus 2 right now. I'm just focusing on this for the time being. Okay, so if we combine that 3 times and then a parentheses x plus 4, and then 1 times 3 is 3, you can see again continuous multiplication link on the numerator, even though there's something adding inside the parentheses. From the point of view of the denominator, That's just a black box there. It doesn't care what's there. It just sees a 3 times something. So these 3's can divide each other and become 1. 3 divided by 3 is 1. That's why, as the next step, instead of multiplying 3 times and then the x plus 4, giving you 3x plus 12, etc., the best course of action here is to simply cancel these 3's. So you're left with y is equal to parentheses x plus 4 and then a plus 2. If that's a bit confusing, again, I recommend that you pause this video and then look at the explanation again. It's really about understanding that because you're multiplying a 3 times and then a fraction that has a 3 on the denominator, from the point of view of these 3's, they can cancel out. It would be a different scenario if we had on the denominator something like 3 plus 1 plus x or 3 minus y or whatever. Then we couldn't cancel the 3's in that case because you wouldn't have a continuous multiplication link. Okay, so now that we're here, what is the next step? Well, the parentheses here is not really doing anything, so I can just remove it. So I'm left with this expression, which leads to x plus 6, the final answer. So now if I look at my choices,